we have yet to talk about non-perfect squares, because there's a lot more square roots that are not perfect. Especially if don't have a calculator, working with non-perfect squares are a little more tricky. They do require knowledge of perfect squares, so if you're still struggling with perfect squares, you need to go back and work on those. But working with non-perfect squares, in reality, you're going to calculate them using benchmarks. Then just estimate. Now, a benchmark is where you take two perfect squares that are close to the non-perfect square that you are working with. One of those perfect squares being larger, and the other perfect square being smaller than them. But it's the next two closest ones. So let's look at the example, the square root of 60. Well, the square root of 60 can be thought of as being close to the perfect square 64, and the square root of 64 is 8. And it can also be seen as being close to the square root of 49, which is 7. So the square root of 60 is found somewhere in between the square root of 49 and the square root of 64, meaning the answer has to be something around 7 point something. Next, we need to figure out, well, is the square root of 60 closer to 64 or 49? And if we check, 60 is only 4 away from 64. So I would count up 61, 2, 3, 4. And it's 11 away from 49. So it's quite a big difference between them. So that must mean that the square root of 60 is closer to 8 than it is to 7. So it's not in the middle. So it's not 7.5. It's closer to 8. Now I'm going to estimate it as 7.7. I've done these quite often, so I've gotten a pretty good handle of what a good estimation would be. And if I check it with a calculator and plug in the square root of 60, I find out that it is 7.7. So my benchmarking was pretty good, and my estimation was even better. Awesome. So let's check another one. What's the square root of 32? Well, the next closest above is 36, and the next closest below is 25. Square root of 36 is 6. And the square root of 25 is 5. So my answer has to be somewhere in between 5 and 6. So 5 point something. Now 32 is closer to 36. So that means my answer will be closer to 6 than it is to 5. So I would estimate it to be about 5.7, because 7 is closer to 6 than it is to 5. So I would say the square root of 32 is about equal to 5.7. Check it with a calculator, and yeah, my estimation is pretty good. Now we can apply this to working with decimals and fractions. We'll look at decimals first. With most decimals, we'll just round it to the next closest whole number. And when we round it to the next closest whole number, well, now we're just using benchmarks again, because that's what we did with our whole numbers last time. So if I was trying to figure out what is the square root of 12.8, well, that's about equal to the square root of 13. The next closest square root to 13 is 16, and below it is 9. Now 13 is closer to 16 than it is to 9. It's only 3 away from 16. It's 4 away from 9. So it is pretty close to the middle, but it's not exactly. So I would say it's about 3.6, because it will be closer to 4 than it would be to 3. So my estimation for the square root of 12.8 would be about 3.6, which if I check it with a calculator, that's exactly what I find. Now working with fractions are a little more tricky, but because we don't care about what is the square root of the whole thing. We only care about what is the square root of the numerator and what is the square root of the denominator. We can actually just deal with each piece individually. So with fractions, we'll estimate them again, but we'll change the numerator and the denominator to the closest perfect square. So if I was working with the square root of 4 over 10, I would simplify it first to 2 over 5. Now I don't actually have to do that, but we should be always in the habit of simplifying our fractions first. Now once I simplify it to 2 over 5, that's like the square root of 1 over the square root of 4. 1 being the closest perfect square to 2, and 4 being the next closest perfect square to 5. So the square root of 1 is 1, and the square root of 4 is 2. So I get the square root of 4 over 10 is equal to 0.5, or 1/2. When I plug this into a calculator, it still works. It's not a perfect answer. I get 0.6, but that's pretty close, and for estimation purposes, that's good enough. What you guys are going to work on now are the questions that will be assigned to you, and we'll come back and do a couple more questions in a bit. Pause the video now. So considering our last one didn't give us a very good estimation, it was still fine, it just wasn't great. I'm going to show you guys an alternative way to work with decimals, especially those decimals that would be between 0 and 1, something like 0.4 or 4/10, which is what you had just seen. So we can do this in two methods. The first method is exactly what we did in the previous one, using 4/10. Now I can make it a little bit better by just not simplifying it, doing the square root of 4 over the square root of 10, which becomes the square root of 4 over the square root of 9, because 4 is already a perfect square. And that would give me 2 over 3, which is about equal to 0.67. Or 0.7-ish. The other method, which is the preferred method, but much harder to be able to do all the time, is we'll change to a perfect square like decimal. So in the previous classes, we saw that perfect squares for decimals tend to be even number of decimals, where 0.4 only has one decimal place, so that's not even. So if we change that 0.4 to 0.40, now it would have an even number of decimal places. And we'd be looking for a perfect square that more or less is 40. So the one above it is 0.49, which is 49, and the one below is 0.36. 0.36 is 0.6 when taking the square root of, and 0.47 is 0.7, which gives us, well, is it closer to 4.9 or closer to 0.36? Well, it's closer to 0.36. So that means 0.4 is about equal to something like 0.64. And if we do that, square root of 0.4, that's 0.63. So that's a much better estimate. Does that mean the other ones are bad? No, they're fine. They're okay. But there are better methods. The last thing we need to work on today is Pythagorean theorem. You learned this last year, but Pythagorean theorem is where you have any right angle triangle. The square of one leg plus the square of another leg will equal the square of the longest side, which we call the hypotenuse. So you would use a squared plus b squared equals c squared if you know the legs, aka a and b. Now, if you don't know a and b, but you know the hypotenuse, you can use the c squared minus a squared equals b squared. The problem is you won't be given this second one on the PAT. You'll only be given a squared plus b squared equals c squared, letting you know that c is the hypotenuse, or the longest side. So if you want to use c squared minus a squared equals b squared, or something like that, you will need to memorize that. So you'll have to remember, if I'm looking for the hypotenuse, I add. If I know the hypotenuse, I'm going to subtract. Because remember, the hypotenuse is always going to be the longest side. So let's look at an example. So let's say I had the right angle that had a leg of 8 centimeters, a leg of 15 centimeters, and a side marked as A. Now, that A does not tell me that it's a leg. It just tells me that's the variable they decided to use. So I have to identify what's the longest side. Well, that side that's labeled as A happens to be the hypotenuse. It's the longest of the three sides. It's also opposite of the right angle. So I am looking for the hypotenuse, so that's a squared plus b squared equals c squared. I'll replace a with 8, b with 15. Square 8, get 64. Square 15, 225. And those equal c squared. When I add those two numbers together, I get 289 equals c squared. But I don't want to know what c squared is. I want to know what c is. So we found out the last class that if I have something squared, I can always take the square root of it to get whatever that number is. So if I take the square root of c squared, I'll be left with c. So if I took the square root of the right side, I need to take the square root of the left side. So the square root of 289 will equal c. The square root of 289, you may know it, you may not. If you plug it into a calculator, you'll get 17 centimeters. And if it was on your no calculator portion of your PAT, they would be fairly easy numbers to work with. Nothing like the square root of 289. But bear with me, it still always will work. And now we have our answer of 17 centimeters. Let's look at another example. Now let's flip around that triangle and give us a side of 10 centimeters, 7 centimeters, and another one just labeled B. We need to label our hypotenuse, which is the side opposite of the right angle, which is that little square in the corner, telling me that that is 90 degrees. Well, I've labeled that the hypotenuse. Now I know the hypotenuse. I want to find a leg. So I'm going to use the c squared minus a squared equals b squared. Replace the c with 10, the a with 7, and now it's just 10 squared minus 7 squared. 10 squared is 100, 7 squared is 49, so that's 100 minus 49 equals b squared. 100 minus 49 is 51, which is equal to b squared. Again, I don't want to know what b squared is, I want to know what b is. So I'll take the square root of both sides, and I'm left with the square root of 51. Now the square root of 51 is one of those ones that we could just use benchmarks for. So the square root of 51 is closest to the square root of 64 above it, and the square root of 49 below it. Square root of 64 is 8, and the square root of 7, or 49, is 7. 51 is much closer to 49 than it is to 64. So that must mean our answer is closer to 7, being something like 7.1. So that's what I will put. I'll say b is equal to the square root of 51, which is about equal to the square to 7.1 centimeters. And now we have our answer. I can check it with a calculator to make sure. Square root of 51 is 7.14. Close enough. So you'll finish up working on the questions that you were working on before and the next couple that will be assigned to you shortly. Good luck, and I will see you guys tomorrow.